This video is about proving quadrilaterals are rectangles, rhombi, squares, and parallelograms inside of coordinate plane. So this is the question. Kalina is experimenting with a new drawing program on her computer. She created quadrilateral TEAM with coordinates here. Kalina believes that she created a rhombus, but not a square. Prove that she's correct. So let's check this out. If we plot the points, it should be this. If t is at -2, 3, we'll go over 2 and up 1, 2, 3. This is t. We plot the other point. E is at -5, 1, 2, 3, 4, 5, and down 4. Point A is at 2, -1. And point M, and M is at +5, +6. Here's the shape. We'll go connect those dots. And if I want to know whether or not it's a parallelogram, I should test to see if any of the sides are parallel. So we're looking at this side, it's TM. It needs to be parallel to this side. To know that, I need to find its slope. So if I look at TM, I can find the slope has to be, you count over 1, 2, 3, 4, 5, 6, 7. So 7 to the right. And it rises 1, 2, 3. So 1, 2, 3. 3 up. So the rise of a run would be 3/7 for TM. So the slope of TM is 3/7. If this slope is the same, it may be a parallelogram or a trapezoid. So I'm going to check that one. If I go over and up, I can go over 1, 2, 3, 4, 5, 6, 7. So 7 over, up 1, 2, 3. So that slope is also 3/7. So these two lines are parallel. So it's on track, and it may be a parallelogram. Let's test the other pair. If TE is parallel to MA, then it may be a parallelogram. Our goal is to prove that it's a rhombus and not a square. So let's first prove it's a parallelogram. So if that's true, then I can go over and down. And if you notice, I should go over 1, 2, 3. So over 3. And down 1, 2, 3, 4, 5, 6, 7. So it's 3/7. So that slope is 3/7. Oh, I'm sorry, read it 7/3. Make that look a little better. It's too light. So it's 7/3. And looking at the other side, this slope would be, I can go over and down. So if you look at it, it's definitely over 3 spaces. It's definitely over 3 spaces. And it's down 1, 2, 3, 4, 5, 6, 7. So that slope is also 7/3. So these two lines are parallel, but they both have slopes of 7/3. So it is a parallelogram. If it was a square, then that would mean these two lines would be perpendicular to each other. They'll form a right angle if it was a square. So the slope here, slope there, was 7/3. Its perpendicular slope should be -3/7, because perpendicular lines have opposite reciprocal slopes. And looking at this line's slope is +3/7. So since it's +3/7, not -3/7, they can't be perpendicular. So in this case, I got all sides being parallel, but this angle is not a right angle. So if the opposite between a rhombus and a square, it has to be a rhombus. We could also prove these sides are congruent. but our goal is to prove whether or not the rhombus are a square. So this is definitely a rhombus. Let's look at one more just like it. All right, so in this problem, Aziza has to prove that the quadrilateral is on with coordinates given there is a rectangle, and use the coordinates to help Aziza show that that quadrilateral is a rectangle. So apply the points, and this would be the quadrilateral is on. All right, we're going to prove it as a rectangle. I had a tip about proving as a parallelogram first. So let's first start proving that these sides are perpendicular. And that can help me prove as a parallelogram. So if I looked at the triangle forming these sides to find a rise over run, it looks like I run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I run up 1, 2, 3, 4, 5, 6. So the rise over run of this segment is 6 over 10 or 3/5. This must be opposite reciprocal of it in order for it to be a right angle. So if we look at that one, its slope, we make a right triangle here, and look like go over 1, 2, 3. It's to the left. It rise up 1, 2, 3, 4, 5. So it's 5 up. So the slope here is rise 5, run -3. So those are two slopes. So perpendicular lines have the opposite reciprocals. So that is a perpendicular slope. It is the opposite. One's positive, one's negative, and the reciprocal of the first line. So I know this forms a right angle. Now, if this line is parallel to this one, then it will form a right angle there too. So let's check it to see if it's parallel. So checking here, making a right angle. This goes over 1, 2, 3, 4, 5, 6, 7. So that goes over 10. If you count it up, it goes up 1, 2, 3, 4, 5, 6. So it goes up 6 over 10 as well. So that line slope is also 6 over 10 or 3/5. So that tells me this line and that line are parallel. If they're parallel, that means these two angles are congruent. And also these are parallel and those two angles are congruent. Then that means that these two angles are congruent. So I need to know for sure that this side is parallel to the other. So let's check that as well. So checking here, dropping a right angle. This goes over 1, 2, 3. It goes up 1, 2, 3, 4, 5. So the slope is 5 over 3. Better yet, -3. 5 over -3. So these two are parallel because both of their slopes are 5 over -3. So it tells me this angle is worth. Since these lines are parallel and these lines are parallel, all these angles are congruent and they all are 90. So yes, it is a parallelogram with 4 right angles. Or even better, yes, it is a rectangle. Because by definition, it's a parallelogram with 4 right angles. That's all I have on that. Good luck.